Okay, so picture this. It's a Saturday afternoon. You're in a park, maybe down by the river. It's a gorgeous day.
All right. Perfect day.
Perfect day, blue sky, perfect light, just enough of a breeze to keep the bugs away. And then you hear it.
That sound.
That like angry, high-pitched mosquito whine.
Yeah.
You look up, and there it is, a drone. It's hovering maybe, 200 feet up, blinking its little LED lights, and it's just watching.
Filming, hopefully.
Right, filming. And we know, just purely from the statistics, that the footage that little robot is capturing is probably incredible.
Oh, absolutely.
We are talking 4K resolution, stabilized, cinematic views of the city skyline or the autumn leaves. It's stuff that maybe 10 years ago would have cost $10,000 in a helicopter to get.
For sure. The barrier to entry for professional-grade aerial cinematography it's basically evaporated. You can buy a device for a few $100s now that outperforms Hollywood gear from, the early 2000s.
But here's the tragedy. And I'm going to call it a tragedy because, honestly, the waste is just painful. What happens to that footage?
Right.
That drone lands. The pilot packs it up. They go home. Then what?
In 99% of cases, nothing.
Nothing.
It goes into what I call the hard drive graveyard.
Yes.
It sits on a micro SD card until that card is full, and then maybe it gets dumped onto an external hard drive in a desk drawer.
Maybe.
Maybe, if we're really lucky, the pilot edits a 30-second clip for Instagram to get that little hit of dopamine from the likes. But the rest of that 20-minute flight, the raw data,
gone.
It's dead. It's lost value.
And that is exactly what we are digging into today. We're looking at a stack of documents here, a business plan, a vision document, and a very, very dense software requirements specification for a platform that wants to stop that waste.
It's a project that goes by a couple of names in the documentation. Sometimes you'll see it as OpenAerial, other times it's SkyShare AI.
Yeah, the branding seems to be a bit in flux.
It does. Seems like they're in that pre-launch phase, but the mission is singular.
And that mission is to turn that hard drive graveyard into a living library of the Earth. It's a platform that claims to be the missing link in the drone economy.
And that's a bold claim, because the drone market right now, it is a mess.
A mess how?
It's incredibly fragmented.
Okay, so let's set the scene before we dive into their solution.
Yeah.
When you say fragmented, what does that landscape actually look like right now? Because I feel like I see drone stuff everywhere.
You do, but it's all in these little silos. Think about the tools a pilot uses. You have the social layer, right? Things like drone Senstagram.
Which is basically just Instagram for drone pilots.
Exactly. That's all it is. It's a photo community. It's great if you want to win a photo of the week contest or, show off a really nice sunset, but it's purely aesthetic.
It's not a functional tool.
Not at all. It's not about video utility. It's about the wow factor, not the data factor.
Okay, so then you've got the editing layer. I see ads for these all the time. Tools like Rav.ai or Lightcut.
Wow. And these are AI editors, but for the individual. You feed it your footage, it cuts it to a beat, you post it. It's a one-way street. The footage stays with you.
It doesn't go anywhere else.
It doesn't. It's a solitary experience.
And then on the far, far end of the spectrum, you have the heavy industrial stuff.
Right, the really technical end. BioDrone, Open Drone Map, these are heavy, very technical tools for surveyors and engineers.
So what are they doing?
They take thousands of still images to make these super detailed 2D maps, usually for construction sites or forestry management.
Okay.
They're brilliant at what they do, but they are totally siloed from the creative market. You aren't going to find a cinematic shot of a sunset on Open Drone Map. You're going to find a topographical survey of a quarry.
So you've got pretty pictures on one side, industrial maps on the other, and this massive void in the middle where petabytes and petabytes of video footage just go to die.
Precisely. And that is where OpenAerial or SkyShare, whatever they call it, is trying to plant its flag.
Okay, so the mission for this deep dive is clear. We are going to tear apart these documents. We're going to look at the tech stack, the money, the ethical questions, because there are definitely a few, and figure out if this thing can actually work.
And I think we should start with the core concept. The elevator pitch that you find right in the preamble of their business plan.
I read that preamble. It was surprisingly philosophical for, technical document.
It was, yeah.
It proposes combining three things that, honestly, I hadn't really thought about putting together. Crowdsourcing, AI stitching, and monetization.
It's a trifecta. And aha moment here, the thing that makes us different from just another stock footage site like Shutterstock, is the granularity.
Explain that. What do you mean by granularity?
Okay, so on a normal stock site, you sell a clip, someone buys the clip. Done.
Right. Simple transaction.
Here, the proposal is that you contribute raw footage to this massive churning engine. The AI takes your footage, it stabilizes it, and then it stitches it together with footage from other people to create something brand new. And then, and this is the real kicker, you get paid based on the exact seconds of your footage that survive in the final product.
That's wild. So I don't need to shoot a whole documentary.
Yeah.
I just need to fly over my neighborhood, and if, say, 3 seconds of my video helps stitch together a map or a timeline of my town, I get paid for those 3 seconds.
That's it, exactly. It connects contribution directly to monetization using what they call transparent rights. It's trying to turn passive archiving into active income.
Okay, that sounds great in a pitch deck. But I want to know how the machine actually works. I was looking at the software requirements specification, the SRS, and they describe the product as a 3-legged stool.
Right, and if you chop one of those legs off, the whole business model just collapses.
So leg 1 is contribution and metadata. Now, when I upload a video to YouTube, I just drag and drop, maybe I add a title. This looks very different.
Very different. This system is like allergic to dumb video. It needs smart video.
Right.
If you look at Appendix A in that business plan, the metadata requirements are intense.
Intense is the word. It's not just date and time. We're talking GPS latitude, GPS longitude, altitude. Okay, that seems standard.
Sure, that's the basic stuff.
But then it asks for lens field view. Why on earth does the system need to know my lens FOV?
Physics. Think about it geometrically. Imagine you are the AI.
Okay.
They're trying to stitch together 2 different videos. One was shot from a drone at 100 feet with a really wide-angle lens. The other was shot from 300 feet with a zoom lens.
Right, I'm picturing it.
To the naked eye, those might look like they're checking out the same building, right? But the scale is completely different. The perspective distortion is totally different.
Oh.
If the AI doesn't know the field of view, essentially, how wide the eye of the camera was open, it can't mathematically normalize those 2 images.
It's like a jigsaw puzzle.
It's like trying to assemble a jigsaw puzzle where half the pieces are magnified and the other half are shrunk.
It wouldn't fit. You'd just be jamming pieces together that don't belong.
It would be a complete mess. The FOV data lets the AI scale everything to a common shared reality.
The list goes on, though. They list nice-to-haves, like pitch, roll, and yaw.
So those are the orientation axes of the drone itself. Pitch is nose up or down, roll is banking left or right, yaw is turning.
But why is that critical? Can't the software just see that the horizon is tilted?
It can, but that takes processing power. It has to guess by looking at the pixels. It's computationally expensive.
Right.
But if the metadata tells the system, hey, at this exact second, the drone was banked 15 degrees to the left, the AI can mathematically correct the horizon line instantly. It saves a massive amount of computing time.
And speed is money.
Speed is money in cloud computing, absolutely.
They also ask for flight path polylines.
That's the breadcrumb trail. It's the 3D map of where the drone moved through space during the recording.
And this all leads to what they call GPS sanity checks. I love this term. It sounds like something out of a sci-fi movie.
It's a great fraud prevention tool.
How so?
Okay, let's say you upload a video and you tag it New York City because you know you can sell that to a high-value market.
Right, prime real estate.
But the GPS metadata that's actually embedded in the file says you were in a field in Ohio.
Busted.
Immediately. The system flags it before it even hits the ingestion server. It also helps with duplicate detection. If you try to upload the same file twice, or if someone steals your footage and tries to upload it as their own, the system sees that digital fingerprint, the time, location, flight path is identical.
So that's leg 1, getting the smart data in.
Yeah.
Leg 2 is the engine, the AI processing, and this is where it starts to feel bit like science fiction for me.
This is the secret sauce. The document specifically mentions something called a Vision Drone 2 technical pipeline.
It claims to solve the boring part of editing. And as someone who has tried to color grade drone footage, I can confirm it is incredibly tedious. You sit there for hours just tweaking sliders.
It starts with what they call ingest and score. The AI doesn't just accept the file, it watches it, and it judges you.
It judges me. Like a film critic.
In a way, yeah. It scores the footage. Is it shaky? Is it out of focus? Is the horizon wobbling all over the place? If the score is too low, it just rejects the file. It keeps the quality of the library high. But if it passes, it moves to the alignment phase.
And this is where I saw the term optical flow stabilization. How is that different from, the normal stabilization I have on my phone?
Standard stabilization often just tracks a few high contrast points in the image and tries to keep them steady. It can look a bit jittery.
Right.
Optical flow is a computer vision technique that looks at the apparent motion of every single pixel between frames. It understands the fluid movement of the entire image.
So it's smoother.
It allows for incredibly smooth, natural stabilization without that weird warping or jello effect you sometimes get with cheaper software.
And then visual feature matching is what links the shots together.
Exactly. So if I filmed the Golden Gate Bridge from the east and you filmed it from the west and our flight paths crossed over, the AI identifies the bridge in both of our videos.
It knows it's the same object.
It knows. It uses that object as an anchor point to stitch our two separate realities together.
Creating what the SRS calls seamless compilations.
And it goes really deep. It handles color matching. So if you shot in a flat, desaturated profile, which pros often do to capture more dynamic range,
Right, log footage.
and I shot in a vibrant, high contrast profile, the AI normalizes them so they look like they came from the same camera on the same day. It can even do speed ramping,
Speed ramping.
speeding up or slowing down footage to match the pacing of a compilation. So if the music beat picks up in a reel, the AI can slightly accelerate your clip to match the rhythm.
That is seriously impressive.
Yeah.
But I looked at the non-functional requirements, which, let's be honest, is usually the boring part of the document where they talk about server load. And there was a number that jumped out at me.
The processing time.
Yes. It says the AI must process a 5-minute compilation in under 10 minutes.
That is aggressive. That is near real-time rendering.
What does that tell us about the infrastructure they're planning?
It tells us they aren't running this on a laptop in a basement. It implies a heavy, heavy reliance on distributed cloud computing, probably AWS or Google Cloud, using GPU clusters.
Okay.
They're likely using what's called job queues, where they break the video into hundreds of tiny chunks, send them to 50 different servers to process simultaneously, and then stitch them all back together at the end.
It sounds expensive.
It is expensive, but it's the only way to hit that kind of speed.
So we have smart data in, we have a powerful engine processing it, but we need to talk about leg 3, the thing that actually makes this a business and not just a cool science experiment. The money.
The monetization and rights layer.
Right. The starving artist problem.
Right.
We all know that drone pilot who spent $2,000 on a Mavic 3 and hasn't made a single dime back. How does OpenAerial solve this?
They propose a 70-30 split. The platform keeps 30%, the contributors share 70%.
That seems remarkably fair. I mean, standard stock sites can take 50, even 80%.
It is very creator-friendly. It's mimicking the creator economy models we see in other sectors rather than those old predatory agency models. But the real complexity is in how that 70% is shared.
Okay.
It relies on what they call the attribution graph.
The attribution graph. This sounds like the brain of the whole operation.
It is. In a traditional model, ownership is binary. You own this clip, I buy this clip. Simple.
Right.
But here, the product being sold might be a supercut of a city skyline that uses frames from 20 different pilots.
So how do you slice that pie? It sounds like an accounting nightmare to track.
You slice it by the frame. The attribution graph tracks exactly which frames from which original source file ended up in the final render. It's granular down to the split second.
Let's walk through the math. The business plan gave a specific example that I found really helpful.
Right, the city reel one. Let's say a broadcaster, maybe the BBC or CNN, buys a 90-second city reel of Chicago. They pay $199 for the broadcast license.
Okay, so $199.
First, the platform takes its 30% cut. That's £59.70. That goes to keep the servers running, pay for all that expensive AI processing, and keep the lights on.
And that leaves £139.30 for the contributor pool.
Exactly. And that money is distributed pro rata.
So based on how much you contributed.
Correct. Let's say your footage was really good and the AI used 9 full seconds of it in that 90-second reel. That means you provided 10% of the value of the final product.
So I get 10% of the pool.
You get £13.93.
For 9 seconds of video.
For 9 seconds of video that was just sitting on your hard drive. And remember, that video is still in the library.
Oh, right.
It can be used in 100 other compilations. It's residual income. You aren't selling the file exclusively. You are licensing the utility of those frames over and over again.
That changes the whole incentive structure.
Yeah.
I don't have to worry about making a perfect finished film. I just need to capture high-quality raw ingredients.
It democratizes the value chain. You supply the bricks, the AI builds the house.
But who's buying the house? Who are the customers here? Is it just news stations?
The financial plan identifies a few key segments. Tourism boards are a huge one.
I can see that.
They always want authentic, fresh visuals of their locations, but organizing a shoot is a logistical nightmare. They don't want to hire a helicopter crew every single time they need a shot of the pier.
Right. They can just log in and grab it.
NGOs are another interesting one they mentioned.
NGOs. Why?
Think about an environmental group tracking deforestation or illegal mining. They don't need pretty. They need thematic aerial data. They need to see the ground to prove what's happening year over year.
And real estate developers.
For them, it's about historical timelines. They want to show how a neighborhood has gentrified or developed over 5 years to pitch their new condo project. They need to show the story of the location.
The pricing strategy is interesting too. It's tiered.
Very tiered. An editorial license, so standard news use, is cheap, around $25. It's a high-volume, low-margin play.
Okay.
A web commercial license bumps up to $55.
And the broadcast license we mentioned is $199.
Yeah.
But then there's this other one, the Enterprise API.
That is the heavy hitter.
It's listed at £1,000 a month. What do you get for $1,000 a month?
You get the fire hose. You get big data access. The plan mentions a 1 terabyte delivery cap. This isn't for a video editor making a YouTube video.
No.
This is for mapping companies, tech firms, or large urban planning departments.
So they aren't just clicking download on a few clips.
No, they're querying the database programmatically. They might write a script that says, give me every single piece of footage covering the Florida coastline between January and March of 2024, and the API just dumps that raw data right into their servers.
That feels like the real business here. The pretty videos are the storefront, but the data stream is the warehouse.
In almost every platform model like this, the API is the scalable revenue engine. It's consistent, recurring revenue, unlike the one-off sales of individual clips.
Okay, so the business model makes sense. But for any of this to work, you need pilots. You need an army of people out there flying. How do you motivate them? The documents mention gamification.
And honestly, it sounds a lot like Pokemon Go for drones.
I love that comparison. Tell me about the bounty system. This was in the novel idea section of the plan.
So imagine a newsroom in London. There's a flash flood in a village in Yorkshire. They don't have a crew there. It would take them 4 hours to drive a van up.
But they need that footage for the 6:00 p.m. news right now.
Right. So they log on to OpenAerial. They drop a pin on the map over the flooded village. They set a budget, say a £50 bonus. This creates a bounty.
And then what happens on the pilot's end?
Every registered pilot within, say, a 10-mile radius who has the app installed gets a ping on their phone. New bounty available, flood footage, 5 miles away.
It's literally Uber for breaking news.
That's the idea. The pilots grab their gear, drive over, fly the mission, and upload the footage. If their footage is chosen and used, they get their standard royalty plus the bounty bonus.
That is incredibly smart because it solves the cold start problem.
Yeah.
How do you get content for a platform that has no content? You pay people to go get it for you.
It turns the platform from a passive archive into an active, real-time news-gathering force.
And they have a ranking system, too. You don't just start as a Top Gun pilot.
No, you have to earn your wings. There are skill tiers. You start as a pilot, then you can move up to cadet, and finally, ace.
Is being an ace just for, bragging rights, or does it actually pay?
It pays. Higher tiers unlock higher bounty limits. So maybe a pilot can only see the 20-pound bounties, but an ace can see the 500-pound corporate gigs. The docs also imply better revenue multipliers for top-tier pilots.
And streaks for consistent uploading.
Yeah. If you upload every week, you get a consistent uploader badge. And this isn't just a digital sticker. The algorithm then surfaces your profile higher in buyer searches.
Oh, that's clever.
So if I'm a buyer looking to hire a pilot for a specific job, I'm going to filter by reliable. That badge is proof of your reliability.
There was also mention of team flights.
Which makes perfect sense for large events. If you need to cover the London Marathon, one drone with a 20-minute battery isn't going to cut it.
You need a squad.
You need a squad. So a team of 3 pilots can coordinate. One at the start line, one at the midpoint, one at the finish. They upload everything to a shared project ID, and the platform automatically splits the payout among the team members.
It really is building a gig economy for aviation.
It is, yeah.
Let's zoom out a bit, though. We've talked about making money and playing games, but the novel uses and applications section suggested this platform could actually do some good in the world.
This is where we move beyond just pretty pictures. The potential for a disaster response is really significant.
Like the flood example you gave.
But scale it up. Imagine a wildfire in California or an earthquake in Turkey. Usually, relief coordinators have to rely on satellite imagery, but satellites have serious limitations.
They're on a fixed orbit. They might not be overhead when you need them.
And more importantly, they can be blocked by clouds or smoke. A satellite can't see through a heavy smoke plume from a wildfire, but a drone.
A drone can fly under it.
A drone can fly under the smoke layer. It can get low-altitude, high-resolution data in real time.
So if you have a network of local pilots who are already there on the ground, you can generate a real-time map of the disaster zone while the satellites are still completely blind.
Exactly. And because of that stitching engine, the relief coordinators aren't looking at 1,000 separate video files. They're looking at one cohesive, constantly updated map.
Then there's environmental monitoring. The term they used here was change detection.
This is one of my favorite applications of this tech. Imagine a time slider on a map interface.
Okay, I'm visualizing it.
Because every single piece of footage has that GPS and time metadata, the platform can stack footage of the same location over months or even years.
So you could?
You could literally drag that slider and watch a coastline erode over 5 years, or watch a forest regenerate after a fire, or watch a glacier retreat foot by foot.
It's like a time machine.
It is. And for scientists, that data is absolute gold. It's not just anecdotal, it's measurable. You can actually measure the erosion in pixels.
Historical city timelines was another one.
Same concept, but for urban planning. Building a visual archive of how our built environment evolves. It's incredibly useful for public works to track construction progress, or for historians 50 years from now to see exactly what a neighborhood looked like in 2026.
It all sounds amazing. It really does. But, and there is always a but, when we start talking about putting cameras everywhere, does this get creepy?
It raises the inevitable question of privacy and the Wild West nature of airspace.
I mean, if I'm sunbathing in my backyard, I don't necessarily want my neighbor's drone footage of me to end up in a global database that anyone can search for 25 quid.
The creators of the platform clearly anticipated this friction. The compliance and governance theme in the SRS is very, very heavy. The platform is designed to act as a gatekeeper.
How so?
First, on the safety side, they have remote ID and geofencing integration baked in.
Let's define remote ID for people who might not know what that is.
Think of it like a digital license plate for your drone. It's a radio signal that broadcasts who you are and where you're flying in real time.
And geofencing.
That's a virtual fence. The system checks no-fly zones during the upload process. If you upload footage, the system checks the GPS tags against a massive database of airports, prisons, nuclear power plants, all of that.
So if I flew near Heathrow Airport,
The system would flag it immediately. It sees the coordinates were within a restricted zone. It automatically quarantines the footage. It won't be published until you provide specific proof, like an unlocking certificate from the Civil Aviation Authority, that you had official permission to be there.
that's a strong safety feature. It protects the platform from a lot of liability. And the documents mention the UK context specifically.
They do. They reference the CAA, the Civil Aviation Authority, and CAB 722 guidance. This is crucial because the regulatory landscape is shifting right under our feet,
The timeline mentions January 1st, 2026.
which, according to their roadmap, is basically now. Remote ID becomes mandatory for certain classes of drones starting then, with full coverage expected by 2028. This platform is designed to be remote ID ready. It expects that digital license plate data to be there.
Okay, so that keeps the airplane safe. What about my privacy? What about my sunbathing scenario?
They align with GDPR, the big European data protection law, and the ICO, the Information Commissioner's Office here in the UK. The AI pipeline is designed to include face and plate blur.
Automated blurring.
Yes. Before the footage is ever delivered to a buyer, the AI scans it for human faces and vehicle license plates. If it finds them, it blurs them out automatically.
That is smart. It sanitizes the data before it even goes out the door.
And there's also the concept of privacy zones.
What's a privacy zone?
Pilots or system admins can designate specific geographic areas, say a school, a hospital, or even a private residence, as a privacy zone. Any footage uploaded that looks into that zone is either restricted completely or heavily redacted.
So it's privacy by design, not just an afterthought they bolted on.
It has to be. If they want to sell to big enterprise clients, these are large, risk-averse corporations, they cannot be selling potential lawsuits. They need clean, legal data.
True. Okay, so Let's look at where this project actually stands. We've been talking about it like it's a done deal, but let's look at the roadmap.
It is a very, very tight timeline. According to these documents, September through November of 2025 was the MVP build the minimum viable product.
Right.
That's when they built the basic ingest system and the version 1 stitching engine.
Then December 2025 was the closed beta.
With just 200 pilots. A small, controlled test group to break the system and find all the bugs.
And that brings us to today, January 2026, which means we are right on the cusp of the open beta scheduled for February 2026.
This is the critical moment. This is when the floodgates open to the public and we see if the servers can handle it.
And looking ahead, what are the big features on the horizon?
Two things really stand out to me. First, plugins for Premiere Pro and DaVinci Resolve.
Oh, that is a game changer for editors.
Think about the workflow. You're a video editor. You're cutting a documentary in Premiere. You realize you need an establishing shot of Paris. Currently, you have to minimize Premiere, open a browser, go to a stock site, log in, search, download, unzip, import back to Premiere. It completely breaks your creative flow.
It's a lot of friction.
With a plugin, you just open a panel inside Premiere, you search Paris, you drag the clip right onto your timeline. The watermarked version is there instantly. If you like it, you click buy. The licensing happens in the background, and the high-res version just swaps in.
Editors are lazy. I can say that. I know a few. And if you make it that easy for them, they will use it. It removes the barrier to purchase.
Exactly. And the second big feature is that enterprise API we touched on, that direct integration for the big mapping companies.
Let's talk about financial viability. Is this business actually going to make money? Or is it just going to burn cash on server costs until it dies?
The financial plan is, I would say, cautiously optimistic but aggressive on the growth curve. The year one goal is pretty modest, £82,500 in revenue.
That's not a lot. That's barely enough to pay one good developer and cover the cloud bill.
It's a proof of concept year. They're just testing the water. But then you look at the year three goal.
Over £900,000 in revenue.
That is a 10x jump in 2 years.
And where's that growth coming from? Is it just selling more clips?
It confirms what we suspected earlier. The key driver is the API business. They expect the API to bring in £420,000 by year three, almost half the total revenue.
That proves the point. The data is worth more than the video.
It is the aggregation that creates the value. One video of a beach is a nice stock clip. 1,000 videos of that beach over 5 years is a data set on climate change. A data set is worth a lot more to a corporation than a single stock clip is to a YouTuber.
That is a powerful distinction. Okay, let's bring this in for a landing. We've covered a massive amount of ground here.
I have.
To summarize, OpenAerial, or SkyShare AI, is a massively ambitious attempt to unify this fragmented drone market. It wants to take the hard drive graveyard, all that wasted footage sitting in drawers, and turn it into a searchable, monetizable asset.
It relies on those 3 pillars. Crowdsourced supply, getting millions of pilots to actually upload their stuff, AI processing, making that mess of data usable and stitched together, and rights management, making sure everyone gets paid fairly.
And it creates a fair trade model where you get paid for every single second your work is used. It effectively creates a stock market for reality.
That's a great way to put it, a stock market for reality.
But here's where it gets really interesting for me, and maybe a little philosophical.
Go on.
We are building a world where almost every square inch of the planet is being filmed, cataloged, and time-stamped. I call it the panopticon. Now, this platform makes that data useful, which is great. It helps us fight fires, track erosion. It pays artists. But it also means our physical world is becoming as searchable as the internet.
That is the double-edged sword, isn't it?
If I can type in a date and a location and see what happened there from 3 different angles, that changes how we exist in public spaces. Is that a tool for truth? Or is it the end of privacy as we know it?
I think the difference between surveillance and archiving might just come down to who controls the data and who gets paid for it.
How do you mean?
If it is the people, the pilots who are owning their data, and transparency is baked into the system, that's one thing. If it's a centralized state or a single corporation controlling everything, it's something else entirely.
So it's about who holds the keys to the library.
Indeed.
Next time you hear that buzzing sound over your head in the park, look up. You might be looking at a flying camera, but you also might be looking at a node in a global living library of the Earth.
And hey, if you wave, you might just end up in the archive.
That's all for this deep dive. Thanks for listening.